Hello guys, myself Suman P from BIT College, 3rd sem CSE, and I am going to brief about registers and type of registers.
Now I am going to explain what is registers and what are the types of registers. What is registers? Registers is nothing but a group of flip-flop with a common clock input. Flip-flop is nothing but which stores one bit of information. So n number of flip-flops are grouped together to store n bit of binary data. That is nothing but registers only. Registers commonly used to store and shift n bit binary data. Now we need to know what is shift register. Shift registers is nothing but a registers only which stores binary data, and data can be shifted to left or right when clock pulse is applied. Okay, in this, output of one flip-flop is connected to input of next, and also it shares single clock signal. Okay, whatever I explained in the diagram, same thing is given here. Okay. Now we directly move to what are the types of registers. There are the four types of register: SISO, SIPO, PISO, PIPO. SISO means serial in serial out register. SIPO means serial in parallel out registers. PISO means parallel in serial out registers. PIPO means parallel in parallel out registers. First, we need to know about what is serial in, what is serial out, what is parallel in, what is parallel out. Serial in means we apply one bit input at each time. Serial out means we take one bit output at each time. Parallel in means we apply 4 bit as an input at same time. Okay, parallel out means we take 4 bit as output together. Okay, this is serial in, serial out, parallel in, parallel out. Serial in, serial out means here we apply 1 bit of input at a time and we take 1 bit of output at a time. Okay, in serial in, serial out, there are two modes. One is right mode, another is left mode. Right mode, what happens, we apply the data input at left side and the data keeps on shifting towards right side. Okay, in left mode we apply the data in at right side and data keeps on shifting towards left side. And again we need to know about rotate right and rotate left. Rotate right is nothing but what happens is LSP comes back to MSP. What happens? LSP goes back to MSP. LSP is nothing but least significant bit. MSP is nothing but most significant bit. What is the use of this rotate right means which keeps on rotating a same data. Okay. In rotate left, what's happened is MSP goes back to LSP. Happens MSP goes back to LSP. That's it. Next, yeah, whatever I explained in previous serial in, serial out, parallel in, parallel, same thing is given here. Okay. Now we see serial in, serial out shift registers in brief. As I explained earlier, there are two modes in serial out registers. One is left mode and right mode. Now we study left mode. Left mode is data in is given at right hand side of the flip flop. See, data in is given at right hand side of the flip flops, and data we keeps on shifting towards left side, and output is taken at left side only. Okay, all flip flops are is connected to same clock pulse. Here same clock pulse is connected to all flip flop. That is nothing negative clock pulse, which here negative clock pulse is connected to same all flip flop. Okay, initially what happens is data in is 1 and q0, q1, q2, q3 is 0. When we press a clock pulse at first time, input is shifted to q0. That is nothing but q0 becomes 1 and remaining q1, q2, q3 remains as 0 only. When we press a clock pulse at second time, Q0, Q1 becomes 1 and Q2, Q3 remains as 0 only. When we press a clock pulse at the third time, Q0, Q1, Q2 becomes 1 and Q3 remains as 0 only. When we press a clock pulse at fourth time, Q0, Q1, Q2, Q3 becomes 1 and we take the output 1. Okay. Okay. In this, we give input one bit at a time and we take output one bit at a time. Okay, that is serial in, serial out. Let's move to next slide. Whatever I explained in the diagram, same thing is given here. Okay, see here initially Q3, Q2, Q1, Q0 is 0, data in is 1, and when we press a clock pulse at first time, Q0 becomes 1. When we press a clock pulse at second time, Q0 and Q0 1 becomes 1. When we press a clock pulse at the third time, Q2, Q1, Q3 becomes 1. When we press a clock pulse at fourth time, Q3, Q2, Q1, Q0 becomes 1. Now let us move to waveform of this left shift resistors. Initially, data in Q0, Q1, Q2, Q3 is 0. Okay. When data in is 1, when we press a clock pulse at first time, Q0 became 1 at negative edge of a clock pulse. Okay. And when we press a clock pulse at second time, Q1 became 1 at negative edge of the clock pulse. When we press a clock pulse at third time, Q2 becomes 1 at negative edge of the clock pulse. When we press a clock pulse at fourth time, Q3 becomes 1 at negative edge of the clock pulse. That's it. Okay. Now we move to right mode shift resistors. Right mode shift resistors is nothing but reverse of a left mode. Here data input is given at right side and data output is taken at left side. Okay, which also sets a common clock signals. Okay, initially here also data in is 1 and Q3, Q2, Q1, Q0. Okay, 0. Okay, when we press a clock pulse at first time, input is transfer shifted to Q3 and Q3 becomes 1 and Q2, Q1, Q0 remains as 0 only. When we press a clock pulse at second time, Q3, Q2 became 1 and Q1, Q0 remains 0 only. When we press a clock pulse at third time, Q3, Q2, Q1 becomes 1 and Q0 remains 0 only. When we press a clock pulse at fourth time, Q3, Q2, Q1, Q0 becomes 1 and we get output as 1. Okay. Now let us see waveform of its right shift resistors. Okay. Initially data in Q3, Q2, Q1, Q0 is 0. When data in is 1 and when we press a clock pulse at first time, Q3 became what? At negative edge of the clock pulse. Okay. When we press clock pulse at second time, Q2 became 1 at negative edge of the clock pulse. And so on. Q0 becomes 1 when we press clock pulse at fourth time. It's also at negative edge of the clock pulse. Now we see second type of resistors, that is serial in parallel out resistors. In serial in parallel out resistors, while giving the input, we give one bit of input, and while taking the output, we take all 4 bits at a time. Q3, Q2, Q1, Q0 are the outputs. Okay, and here also we shares a common clock signal, that is negative triggered clock pulse. Okay, when input is 1, wait a minute, when the input is 1 and when we press a clock pulse at first time, Q3 becomes 1 and Q2, Q0, Q0 remains 0 only. We get output 1, 0, 0. When we press a clock pulse at second time, That time Q3, Q2 became 1 and Q1, Q0 remains 0 1 and we get output 1 1 0 0. When we press a clockwise at the third time, we get Q3, Q2, Q1 becomes 1 and Q0 remains 0 only. We get output 1 1 1 0. When we press a clockwise at fourth time, Q3, Q2, Q1, Q0 becomes 1 and we get output 1 1 1 1 1 1. That's it. Okay. Yes. Now I am going to explain third type of registers, that is parallel in serial out registers. Here we load 4 bit of input at each time and we take 1 bit of input output at each time. Shift bar load is there, no, which controls the input and which also controls the shifting and loading operations. When the shift bar load is 0, that time loading operations occurs. When the shift bar load is 1, that time shifting operations occurs. When the shift bar load is 0, that time G1, G2, G3 becomes activated and G4, G5, G6 becomes deactivated. When the shift bar load is 1, that time G4, G5, G6 is activated and G1, G2, G3 is deactivated. Okay, this 4 flip flop is connected to single negative triggered clock pulse. Okay, here we apply shift bar load as 0 and we give input as 1 1 0 1. This line becomes 1, NOT gate is there, and when the shift bar load is 0, that time G4, G5, G6 is deactivated. That is nothing but becomes 0 only. G5, G6. Now this comes. A3 is 1, then its output becomes 1. Here each line is 1, no? Then here 1 is there. 1 and 1 means 1. 1 or 0 means output becomes 1. Okay. Here 0 is there. Here 1 is there. 1 or 1 and 0 means 0. 0 or 0 is 0. Here 1 is there and here 1 is there. 1 and 1 means 1. 1 or 0 is 1. Okay. Now I apply shift bar load as 1. Then shift bar load as 1 and then this line becomes 0. We give input same 1 1 0 1. When the shift bar load is 1, that time G4, G5, G6 is activated. G1, G2, G3 is deactivated, is nothing but G1, G2, G3 becomes 0. Here A3 is 1, then the output becomes 1 only, and this line is 1 and 1 and 1 means 1. 1 or 0 means 1 and this line is 1 and here is 1. 1 and 1 means 1. 1 or 0 means 1 and here also 1 is there. 1 and 1 means 1. 1 or 0 means 1. Okay. That's all about parallel in serial out registers. Now we move to fourth type of register, that is parallel in serial out registers. Here we load 4 bit of input at each time and we take 4 bit of output at each time. A3, A2, A1 and A0 is parallel data input. Q3, Q2, Q1, Q0 is parallel data outputs. Here no shifting operation is needed. Shifting operation needed only in serial. Okay. In this also 4 flip-flops share common negative triggered clock pulse. When we apply input as 1, 0, 1, 1 and press a clock pulse at first time, we got output as 1 0 1 1. Okay. When we apply again input as 1 1 1 1, when we press a clock pulse at second time, we got output as 1 1 1. Okay. That's all about parallel in parallel out resistor. Thank you. This is all about resistors and type of resistors.